All right. Is it recording?
Yes.
All right. Okay. So we'll just go through the disturbance for now. Let me show my simulation first, and then um I'll show the results. Okay. Let me share. Can you see my screen?
Yes.
Okay. So um sorry. Okay. So this is basically for the disturbance. I did it two ways. Like I did the derivative blocks, and then I also did the transfer function for velocity and for acceleration. So the result we got is, so the first one is for displacement, then velocity, then acceleration. So for the displacement curve, it basically, the disturbance for displacement initially just pushes the drum away from the equilibrium setting, but then that's when our PID controller is going to come in handy, and then it's going to like do the corrective action, like bring it back to the steady state of 0. So that's what we're aiming for. For the velocity represents like how quickly the drum should be moving. So the increase and decrease in the peak is basically the vibration that is happening in the drum. So that's what we are getting the result for in velocity. For our acceleration, it's like it has the strongest, like sharpest peaks, because this is the most sensitive to disturbance. And this basically is going to represent our rate of change of displacement and, sorry, rate of change in velocity. And it's just more, we just wanted to show that it's more sensitive, how the changes act, the transient changes act in a more sensitive way. So that's why we're doing the acceleration. Do I make sense?
Yeah. So why do you think the responses with the disturbance is more oscillatory?
Sorry, come again.
Why do you think the responses is more oscillatory when you adding in the disturbance?
When we are adding the extra energy using the step input, that is what is causing, like, that's the disturbance, right? So that disturbance basically interferes with the transient characteristics of our, let's say, displacement, velocity, or acceleration, which is why we get this kind of like a deformed kind of graph, which is then why we're going to use our controller to stabilize it, or to make it near a zero steady state, basically. So yeah.
You want me to
I,
explain anything?
I think we will have to add like what effect velocity and displacement has. Um, I think for displacement is basically like the changing of the position, right, of the drum. So I think that we can include it affects the mechanical wear and tear. I think that could be an effect of displacement that we talk about.
So when your tub or drum has more displacement, more acceleration, that means that thing is vibrating more and it
Yeah.
can cause the entire machine to also move.
Yeah, basically, right. Yeah, that's the
Yeah.
problem. So I think, so do you think the
Just
disturbance, yeah,
yeah, yeah. Go
no,
on.
you go ahead.
You go on first.
No, just like, so like the disturbance, the simulation, and like the result is fine, right? We can move forward with this.
Yeah, I think this is good. Can you just briefly show the one without disturbance?
Oh, like the result, or like just the simulation?
Just the response. Yeah.
Okay. Let me see if this runs because my laptop's like really slow. Okay, so this would be like the smooth initial
Mm.
graph that we'll get.
So
That's like basically
because
uncontrolled.
this one you're using the step input, right? And with the disturbance, that's a continuous sine wave.
Yeah,
So
I'm
your
using a sine input.
yeah
Yeah.
yeah so your oscillation is also showing with the
Mm-hmm.
disturbance and not without disturbance. Great.
No. Yeah. So I think we can go with this.
Yeah. Okay.
All right then. Wait. Anything else? Do you have to? Do you want to add? Let me just stop sharing. Then I guess we start working on the individual particle, right?
And so what I understand, then we need to because like with when you're adding in the disturbance, there's like very high peaks for the displacement, acceleration, velocity, and all those. So I think that's what we need to work on,
Mm.
and see which one we want to actually limit. Like, is it the transient phase or is it the steady state phase? Yeah, reduce the peaks basically, I guess.
Yeah.
So if it's lower amplitude, lower vibration,
Yep.
that's
The
what we're
amplitude,
targeting.
I think.
Yeah.
But we have to figure that out. More research on that. But yeah, so far this is what. All right then. Um.